Hello everyone, welcome to Cbse Maths. Today in this video, we are going to solve exercise 7.1, sixth main question. In the sixth main question, here in the second problem, we have to check out which type of quadrilateral these 4 points will make. So, let's consider a point A as minus 3, 5. Let's take point B as 3, 1. C as 0, 3. At last, D as minus 1, minus 4. And let's try to find out which type of quadrilateral these 4 points will form. For that, let's find out the distance between AB, BC, CD and AD. At first, we will write distance formula. D is equals square root of x2 minus x1 whole square plus y2 minus y1 whole square. So this is the distance formula. Then let's consider points A as x1, y1 and coordinates of point B as x2, y2. Then by substituting these values in this distance formula, we have x2 that is 3, x1 that is minus 3. So here we're going to write minus of minus 3 whole square plus y2 means here 1 minus y1 is 5 whole square. Let's simplify it. Square root of, here we get 3 minus into minus 3 that is plus 3 whole square plus here 1 minus 5 that is minus 4 whole square, which gives us square root of 3 plus 3 that is 6 square plus minus 4 square. Further simplification gives us 6 square value is 36 plus minus 4 whole square that is plus 16, which gives us square root of 52. We can simplify this square root of 52, which gives us square root of 13 into 4. We have the square root of 4, which is 2, so we can write the value of AB as 2 root 13. So the value of AB is 2 root 13. Now let's try to find out the values of distance between the points B and C. So BC is equals square root of, consider B value as x1, y1 and let's consider the values of C as x2, y2. The coordinates of C are 0, 3 and the coordinates of B are 3, 1. Let's write that. So coordinates of B are 3, 1 and the coordinates of C are 0, 3. Let me clarify it one more time. So the coordinates of B are 3, 1 and the coordinates of C are 0, 3. Let's substitute it again. So here we can write with the help of distance formula 0 minus 3 whole square, that is x2 minus x1 whole square plus 3 minus 1 whole square, which gives us a square root of 0 minus 3, which is minus 3 whole square plus 3 minus 1 that is 2 square, which is equals to square root of minus 3 whole square is 9 plus the value of 2 square is 4, which gives us square root of 13. So the value of BC is square root of 13. Now let's find out the value of CD. To find the CD, we need the coordinates of C and D. Coordinates of C are 0, 3 and let's find out the coordinates of D are minus 1, minus 4. So let's write that coordinates of D are minus 1, minus 4. Now let's find out distance between C and D using distance formula. So consider D as x2, y2, C as x1, y1. Then we have minus 1 minus 0 whole square plus minus 4 minus 3 whole square, which is equals to square root of minus 1 minus 0, which is minus 1 whole square plus minus 4 minus 3, which is minus 7 whole square, which gives us square root of the value of 1 minus 1 whole square is 1 plus the value of minus 7 whole square is 49, which is equals to square root of 50. We can write this square root of 50 as square root of 25 into 2, which gives us 5 square root 2. So this is the value of CD. At last, let's find out the value of AD. Here we have the coordinates of D, which is minus 1 comma minus 4, and let's write the coordinates of point A. So the coordinates of point A are minus 3 comma 5. Let's write that at here. So A equals minus 3 comma 5. Let's consider A as x1 y1 and D as x2 y2. Then using distance formula we have minus 1 minus of minus 3 whole square plus D value minus 4 minus 5 whole square. Let's simplify it now. Then we can say square root of minus 1 minus into minus 3 gives us plus 3 whole square plus here minus 4 minus 5 gives us minus 9 whole square, which is equals to square root of minus 1 plus 3, which is 2 square plus minus 9 whole square. Let's write it as it is, which is equals to again square root of 2 square value is 4 plus minus 9 whole square is 81. So the value of AD is square root of 85. So if we observe the figure, if we observe the values of all these four line segments of that quadrilateral, AD is square root of 85. Then the value, let's write AB. The value of AB is 13 root 2 root 13. BC is root 13. CD is 5 root 2. At last the value of AD is 85. If we observe these all values, we can say that these all values are completely different from one another. So we can say that this quadrilateral ABCD is not any specific type of quadrilateral or any special quadrilateral. So we can say that this one is the general quadrilateral. That is the solution. I hope you all got this solution. Let's move on to next question. In this question, we have 4 points 4, 5, 7, 6, 4, 3 and 1, 2. Here also we need to check out which type of quadrilateral these 4 points will frame. So let's take A as 4, 5, B as 7, 6, C as 4, 3, C as 4, 3, at last D as 1, 2. And let's find out the distance between AB, BC, CD, at last AD. So let's write distance formula first. D is equals square root of x2 minus x1 whole square plus y2 minus y1 whole square. So let's use distance formula to find out the values of distance between any two points now. Let's first write AB, which is equals to square root of, consider B as x2 y2 and C as x1 y1. Then we have 7 minus 4 whole square plus 6 minus 5 whole square. By simplifying this, we can write 7 minus 4, that is 3 square plus 1 square, which gives us square root of 9 plus 1. So the value of AB is square root of 10. Similarly, let's try to find out the values of PC. So BC is equals to square root of, Consider C as x2, y2 and B as x1, y1. Then we have 4 minus 7 whole square plus 3 minus 6 whole square. By simplifying this, we can write 4 minus 7, that is minus 3 whole square, plus here 3 minus 6, that is minus 3 whole square, which gives us square root of minus 3 whole square, that is 9, plus minus 3 whole square, that is 9, which is equals to square root of 18. We can write that square root of 18 as square root of 9 into 2. We have the square root of 9, which is 3. So the value of BC is 3 root 2. Now let's find out the value of CD, which is equals to square root of the coordinates of point C are 4, 3 and the coordinates of point D are 1, 2. Consider D as x2, y2 and C as x1, y1. Then we have 1 minus 4 whole square plus 2 minus 3 whole square, which is equals to square root of 1 minus 4, that is minus 3 whole square, plus 2 minus 3, that is minus 1 whole square, which is equals to square root of minus 3 whole square, that is 9, plus minus 1 whole square, that is 1. So the value of CD is square root of the value of CD is square root of 10. Now we got the values of all four sides. Let's observe these side values here. CD value is root 10, BC value is 3 root 2, AB value is root 10. Let's find out the last value, that is AD. So AD is equals to square root of, consider the points, coordinates of point A as x1, y1 and the coordinates of point D as x2, y2. Then we have 1 minus 4 whole square plus 2 minus 5 whole square, which gives us square root of minus 3 whole square plus minus 3 whole square, which gives us square root of minus 3 whole square, that is 9, plus minus 3 whole square, that is 9, which gives us square root of 18, which we can write as 9 into 2, which gives us AD as 3 root 2. So now we got the values of four sides of that quadrilateral. If we observe these sides, here AD value is 3 root 2 and the value of BC is also 3 root 2. CD value is root 10. The value of AB is also root 10. So we can say that here opposite sides are equal to each other. Now we have to check out whether this quadrilateral is a rectangle or not. For that, let's find out the side values of AC and BD. That is diagonal values of AC and BD. If diagonals are also equal, then we can say that given quadrilateral is a rectangle. Or even we can check that with the help of Pythagoras theorem. Also, let's check out whether the diagonals are also equal to each other or not. So let's consider first diagonal as is E. So diagonal AC is equals square root of, consider A as x1, y1 and C as x2, y2. Then we can write 4 minus 4 whole square plus 3 minus 5 whole square. By simplifying this, we can write 4 minus 4, that is 0 square, plus 3 minus 5, which is minus 2 whole square, which gives us 0 square value is 0, plus minus 2 whole square is 4, which is equals to square root of 4. So the value of AC is 2 units. Let's find out the value of other diagonal BD also. So diagonal BD is equals to square root of, consider B as x1 y1 and D as x2 y2. Then we have 1 minus 7 whole square plus 2 minus 6 whole square. Let's simplify this. Then we can write square root of 1 minus 7 whole square, that is minus 6 whole square, plus 2 minus 4 whole square, which is minus 4 whole square, which gives us square root of minus 6 whole square, that is 36, minus 4 whole square, which is 62, which is 16. So gives us square root of 52. So square root of 52 means square root of 13 into 4. We can rewrite it as then the square root of 4 is 2 root 13. So the value of BD is 2 root 13. So by checking at the diagonal values, we can say that this 2 root 13 and 2 are completely two different measures. So here opposite sides are equal and diagonals are not equal to each other. It means this given quadrilateral ABCD is a parallelogram. That is the solution. I hope you all got this solution. Thank you for watching the video.